Okay, welcome to our last seminar of the semester. It's great to have Ari Saptanian with us today. He's a professor of economics and the executive director of the Center for Economics and Social Research at the University of Southern California. Before founding the center in 2013, he was a senior economist and director of the Labor Division at the RAND. His research focuses on aging and economic decision-making. He has published numerous papers on topics related to retirement, consumption and savings, pensions and social security, disability and economic well-being. He also founded the Understanding of the America Study in 2014, which is a nationally representative research platform and provides a rich source of data for the study of health in the United States. The de-identified data are publicly available via secure data enclave. And today he will tell us about this rich data source and the numerous possibilities that researchers have for reaching the health of the US population. So please join me in welcoming Ari to the seminar today.
Thanks. So Irma, you're responsible, I think, right? Because we had this delegation we were part of and to visit NIH institutes. And we all had to write a one-pager describing what we're doing. And I think Irma liked what I wrote about the Understanding America study, and that's sort of how I ended up here. It also makes for an unusual presentation, and I'm a little nervous about it because I usually talk about the research, like we're doing something, you have a problem, you have data, you tell about it else. This, frankly, is somewhat of a sales talk because we talk about all the great things about the UAS, the Understanding America study. I'll argue that the data we collect are actually interesting, and I certainly hope that as many people as possible use it. I'll also at the end try to motivate why we're doing this and why I think it's actually important to do this. I'm a little unsure about the timing. I guess I have an hour thereabout. Yeah, and I may have too much. If I have too much, then I'll just skip things. On the other hand, since I tend to be nervous about timing, I may go too fast, so I invite you to interrupt me whenever you think something is unclear or when I'm glossing over things. So it's a bit of an adventure to see how this goes, but I hope you'll share my excitement about the kind of data we're collecting, and at the end I'll try to also put this in a broader perspective by an example. So this is sort of the content of what we're going to talk about, and I'm not going to go through it now. You will sort of see what's going to happen. At the end, you will see there is a bullet point that says why, and the why is then sort of the motivation that I will try to give for why we're doing all of this. But I'll start with a pretty extensive introduction to the UAS and what it does and sort of what we're trying to do. So in some ways, it's straightforward. It's a probability-based internet panel, and I'll explain in a second what I mean by that. We started in 2014, as Irma said, and it has grown over time. We have about 14,000 panel members, and we have really promised our funder, NIA, to go to 20,000, sort of the end of this calendar year, not much later. So it's that's what happens. So respondents are recruited from postal office delivered sequence files, which just is the universe of postal addresses in the United States. So we send people letters. We have a whole process of getting people on board of the panel, and that's how. And that's why it's probability based, because we have a proper sample frame, which is the universe of postal addresses. All servers are on the internet, so that means that people don't have internet, you give it to them. It used to be something that actually meant something. To be honest, it means very little today. Today, every now and then we still give people a tablet if they don't have internet access, and then we pay for it. But it's really, we mainly replace all tablets that die more than that we give new ones. So this aspect has become less important. And then we pay people $20 for every 30 minutes of survey time, and we pay them also for all sort of extra activities you will use. One thing that we really try is to make our data available as quickly as we can, as widely as possible. So anyone who wants to use the data, go to the website, you have to sign a relatively simple form that you have access, and you can do with it whatever you want. So we have a lot of survey data, but then we have textual data I'll talk about is paradata, which is data about how people do surveys, and I'll talk about it also a little bit. Increasingly, we play with wearables, particularly we have activity trackers, particularly Fitbit, but also, for example, Apple Watches. We do air quality monitors, and we have a couple of other wearables that we're thinking of, and I'll talk about a little bit. And I have noticed that this thing has a tendency to progress without me hitting something, so bear with me. And then we do some other things. So we'll sort of go through most of these, but the main point is you want to make data available, and typically try to do this. The moment the survey comes out of the field, it's available on the website, so there should be minimal delay from that. So really, that's why I call it a shared platform. I want people to do as much as possible. Also, if you have money, I'll also be happy to take your money and have you collect more data. And I should mention that the thing though, the restriction we have that if you collect data and you pay us, you still have to promise that you will have the data available on our website. Possibly with some delay, really never more than a year, maybe half a year. And the reason is really by doing that, we have this community where we all collect data and then benefit from other people's data. So you can design everything with loss, I think. But if you have no money, there is still an option because the current grant we have allows us to give away 100,000 minutes of free survey time. It sounds like a big number, but actually, if you think about it, it's actually not that big. But it turns out to be enough. And so 4 times a year, you can submit a proposal. The proposals have to be, first of all, interesting. That's sort of the merit part. And they have to be in line with what the current grant emphasizes. And the current grant emphasizes really health disparities. I used to be saying health disparities and inequality, but inequality is now a word that's verboten, but of course, it's still the same thing. So I have an interest in, what determines people's outcomes today, and that's really what these data are geared towards. So we collect a lot more data than you can collect if you just have one survey every 2 years. So we have now 24 core surveys that are administered on a 2-year cycle. And that the result is about 4.5 hours worth of core interview data that is then collected every 2 years. And of course, this makes for a very rich environment in which you can then also collect more data. In addition, we do monthly surveys. They're roughly 5 minutes or so. And then ad hoc topics. So if you have something that you're really interested in, as I mentioned, we can design a survey, and that will be part of it. So altogether, people do a lot of surveys. And so this is a summary somewhat of the core surveys. We do include the complete HOS questionnaire, for example. We have something like 10 cognitive tests. We ask for personality, we do life satisfaction. We have a financial literacy module, I think about 14 or 15 questions, for example. And then of course we have passive information that you get, for example, from fitness trackers and other sources that we get by just observing people rather than asking questions. So I'm going to sort of address 2 things before I'm going to talk more about what we have. One is that, so we ask all these questions, we do this frequently, people ask the question, maybe twice a month or so. So the question, of course, the concern that people always have is, is this going to create trouble? Does this mean that we burden respondents so much that they're going to run away? So we have done an RCT where we vary the frequency at which people get surveys, and we just want to see whether or not that reduces the response rates. And I can give away the answer. The answer is it doesn't actually. So it just sort of justifies asking a lot of questions because it doesn't really seem to be bad. Because one point is we pay people, right? And somehow how much we pay them seems to be enough to keep you going. So this is the setup. And it's pretty, I don't know why this keeps doing. So we recruit people in batches. So every now and then we send out a lot of letters, and then we try to recruit as many people as possible to the survey. So we expand the panel or replace refreshment. And in this particular case, in January 2024, we sent out almost 20,000 letters, and then went through this process of trying to get people on the internet. We ended up with a little over 2,000. So that's a recruitment rate of a little over 10%. And of course, that's another number that you think, well, that's really very low. So after this, I'll also talk about why actually it's not as low as you think. Or actually, it is low, but somehow it doesn't seem to matter as much as you might think. So in any case, so we end up with 10%. So we have about over 2,000 new respondents. And so here's the treatment. We have two assignments. So we have the high frequency treatment where people get a core survey every 2 weeks. And then we have a low frequency treatment and they get one core survey every 4 weeks. So the point is, does it make a difference if we bother them every 2 weeks or every 4 weeks, right? That's the central point. So the core surveys, and actually earlier on I said we have 24 core surveys when we did this. We had only 21. So what we're going to do in the core surveys, they get, so the 21 core surveys are spread over time, right? So everyone gets the 21 and just get it at a different speed. In addition, as I said, there are also other surveys are called the non-core surveys. And these things are not different. If you look at the two treatment groups, one treatment group gets core survey every 2 weeks and then other things. And the other groups get a core survey every 4 weeks and other things. So the only difference between the two is that the core survey, the rest is the same. Now this is a somewhat complicated table. The first thing to be noted, if you have 21 core surveys, then for the low frequency group, after 41 periods, and the period is 2 weeks, after 41 periods you're done, you've done everyone. The high frequency group is done after 21 periods of 2 weeks. Now, and of course, so what you will do is really just look across rows. So whenever they both do a core survey, what is the response rate? So the core survey, they're not, except for the first one, they're not the same because, you know, after a couple of waves, the high frequency group will have done more core surveys than the low frequency. But you look across, but what you do look, you look across time, and each time you look across the rows, you see that you try to see whether these numbers vary. Now, the problem in this, and I'm sorry about this complication, but it's really hard to avoid, we have the HRS models. And the HRS models actually screw up the experiment. And they do this for the following reason. The HRS models have to be done in a certain order. There's 6 of them, right? So the HRS survey, as you know, is very long. We split it up in 6. But it has to be done in a certain order. That means this frequency where, well, you get a survey every 2 weeks or 4 weeks doesn't work anymore because after the first HRS survey, you can only do the next one if you have done the first one. And you may have done the first one after 3 weeks. So then it's, so in other words, the proper comparison for this is really to look until you hit the first HRS module, and after that you cannot really do that because it's different. So and that's sort of reflected in this table. So this table only goes through the first HRS survey for the high frequency group. And you see the survey waves. So these are the core survey waves, 1, 2, 3, 5 for the low frequency, and then you have 1 through 9 for the high frequency. And you can only compare at cases where you have a wave for the low frequency. And then the last column shows the difference. And lo and behold, if you add them all up, the average difference is exactly 0. So that's where you really don't find any difference. Now, the other thing is that you can then also look at the non-core surveys, and there's no spillover, because you could imagine that you get very tired of having a lot of core surveys, so you don't do the other surveys. Or you really want to have more surveys, and you're happy to do more. So we do find there's no effect on the non-core surveys. There's just no effect, period. And there's also no heterogeneity. So if you look at different groups, you know, once you do proper testing, you really don't find any. So the story is essentially, it seems that you can collect a lot of information, more than you can do traditional surveys, and you don't get biased, right? And of course, that's where the case is, because we like to ask a lot and want more about it. So the other one is, as I said, you know, we have our response rate is improvement is something like 10%, which is in some ways makes you think, well, why would you even bother? Because you might as well go online and invite anyone who wants to do a survey, and you know, you probably get information that's just as good. And that turns out to be not true at all. And there's some reason, but it's not as if there is a mathematical theorem that tells you why this is not true. I mean, it just turns out to be the case that what we call the probability-based surveys are much better than the non-probability surveys. And there is a strand of literature, largely written by John Crossing at Stanford, that sort of finds this time and again. He takes probability-based surveys, then he takes 10 what they call non-prop surveys, and it's always the 10 non-prop surveys are terrible compared to the one probability survey. We have done two things. We have written a paper where we look at, because as I said, we do HRS questions in the US, so we have looked at a number of questions that in HRS, also in the US and also CPS, because we want to see how do HRS in the US compare to CPS. And it turns out that we're actually doing is pretty much the same, despite the fact that HRS has much higher response rate. And as I said, there is an extensive literature, particularly by Tom Crossley and others, that show that the probability-based internet panels where we select samples rather than coming to a survey and say, well, I want to do a survey, are much better. And there is one sort of dramatic example that some of you may have known. And I'm going to show two slides to make a point. And it's sort of inspired by
I think you lost the mic somehow.
Oh.
There you go. Fine. Choose the pattern.
All right. Okay. Thank you. Okay, this graph, I'm going to show this graph, and then the next graph is sort of giving you the punchline. So this is about COVID vaccination starting in January 2021. As you know, the vaccine became available, people started using it. And so we have here lines that tell us the percent of people who got their first vaccination. CDC line is the blue line, and of course CDC knew how many of these shots were given, so that that in some ways that's a gold standard. I don't think it's perfect, but it's sort of reasonably good. Then there is a line that says Axios. Axios paid Ipsos, and Ipsos runs a probability-based internet panel called the Knowledge Panel, and the setup is exactly the same as the US. They had about 1,000 observations per week, so they asked people, did you get a shot? And if you look at that, you see that the Axios line lines up with the CDC line quite well. But of course, then we thought, well, they did. We can also do that because we asked. So we also look at the US line. And the point about these lines is they're all sort of on top of each other. So all these probability-based internet panels seem to be doing pretty well. And also Axios, their response rate is even lower than that. So somehow it feels that it's 10% or not too bad. So now we get to the point, well, but maybe non-prob panels will be equal. So there were during COVID, there were a couple of things going on. So Facebook organized something called the Delphi survey. So they asked 250,000 of their Facebook users every week about things. And also starting in January of 2021, we started asking, did you get a shot? Then there's also something called the census pulse. So at some point, Congress allocated quite a bit of money to the census. I think it's something like 100 or more million, to somehow monitor what was going on in the country. Of course, they felt they couldn't do surveys, they couldn't go to people and ask them directly, so they put together this convenient sample somehow. And of course, if you were the census, I'm sure that they tried really hard. So they had 75,000 observations per 2 weeks. Okay. So this graph to the right is from a paper by Bradley et al. In Nature, and some of you may have seen this. So it certainly got quite a bit of attention when it was published in 2022. So they produced something which they call the bias adjusted effective sample size, which is sort of a mouthful, but what they're doing really is they look at mean square error. And as you know, mean square error has two components, variance and bias. And so what they're saying is, well, some of these surveys may have a big bias, but the variance is probably very small, right? And if you have 250,000 observations, the variance is zero, but there is a bias. So then they ask the question, if instead of a biased sample as big, I had a simple random sample of the American population, how big would that sample have to be in order to get you exactly the same mean squared error? And if you now look at these graphs, and you look at the blue graph first, so that is actually Delphi, and you go to May 2021, the answer is I can start using this.
Yeah. What's wrong with it?
Well,
I guess it's the end of the semester, so all the batteries are
Everyone's
there.
tired.
So-
So this one's.
Yeah.
I'll try to. So the answer is, if you look at the blue line of May 2021, then the 250,000 a week gives you the same mean spread error as a random sample of 10 Americans. Right? But, and of course. If you look at the green line, so that's the census pulse, it's a little better, and it's a logarithmic scale, so I didn't really go back and count, but so the census is doing better. I mean, it's probably equivalent to maybe 20 or 30 Americans. And then you look at Axios, that's the one that they looked in this paper, and that's, as I said, the probability based, and that effective sample size at the end is, and again, it's a logarithmic scale, I'm going to say, maybe 300 or 400. So it's still not great, but you see how a smaller sample at the end of the day gets you more information than a big sample, provided that it's a proper sample. And of course, that's an argument I like to make. That's the argument I make if I tell people they should use UAS. So that's sort of my argument, and I guess the empirical observation why I think that the data is really worth collecting, and also why collecting a lot of information is a good idea, because you just learn more about people when you make more separate surveys. So what I'm going to do now, I'm just going to talk about a number of ways in which people can access the data. And again, can you warn me when it's like 15 minutes or so? Because I want to make sure that have enough.
Yeah, there's a clock right there too.
Let's go.
Near the window.
Yeah.
Right. Oh, you can, yeah.
Okay, I'll go ahead.
Before we let you know too.
I'll just.
Technology is not giving you.
Well, I'm still able to read it, so I guess. Right. So the first thing is, the goal is really to make this data available to as many people as possible. And so one of the things we've started doing is what we call a data explorer. So essentially, you don't have to do anything. You just go to the website and you look at graphs. That's really the point. The two of them, one is about the core data. So these are the 2-year cycle data. And the other one is the monthly sample data. And I'm just going to give you a few examples of each one. So again, the core data is 2 years, as I told. And right now we have about 1,200 variables that you can just play with if you go to the website. And so we can look at 2-year trends. You can also look at distribution by background variables, for example. So one example I'm going to give you is conscientiousness by age group. And there's a reason why I'm doing it. I'll tell you in a second. So this gives you the trend of conscientiousness. It's one of the personality variables that we're measuring. And if you look at the lines, then the lowest line is the youngest group, and then the one above that is next to the youngest group. So the older you are, the more conscientious you are, according to this. But the thing that's striking here is also that the lowest line is going down quite a bit. And so there was a journalist of the Financial Times who used our data and figured this out. And like for a day, this was the big deal. Conscientiousness of young people is falling down, and what's going on and on. So and so he used our data. His graph was nicer than mine, must say. See the same thing. So the monthly data, as I said, we asked about 5 minutes worth of questions, and this is just one example of stress. And you have these different. This is also by age, and the blue line, the sort of dark blue line, is the 40-50, and they seem to have less stress. Now, there's not really a point of showing this because it's just sort of a mess. And actually, if you add 95% confidence intervals, now it becomes sort of impossible to see anything. But of course, the point here is that you can relate here what you find to events. For example, we asked people whether they were subject to a severe weather event, for example, fires in Los Angeles. Right. So the idea is not really to understand so much, but then relate this data to things that previous months. Now let's give you an example. I'm still expanding. Also going to ask. So that's sort of so far survey data. So now I'm going to move to passive data, variables. And this is a project that's run by Ritika Chaturvedi. She had sort of a smaller project, now sort of a big part of the UAS. So the idea is that everyone in the US will try to get them to wear a smartwatch. And the sort of, and on the right, you see, it's merely to show, these are all pallets with Fitbits. So we bought, I don't know, 6,000 or 7,000 Fitbits, and they're all with the stuff, and then we're gradually sending them out. So the way it works, if we ask people if they're interested in participating, so if you look at the table at the bottom, so this is, so far we have a little over 5,000 people have consented to wear a Fitbit, so we give it to them. 512 in this table already had a Fitbit, but they're still participating. We pay them for participation. And there are people with Apple Watches, and then there's some other trackers, in particular Garmin. And then you go to the connected column, and of course, not everyone is connected yet. Work on it, and also, as always, people will consent, and then it never happens. You lose people. So that's sort of where we are at the moment in having people wear that. And the idea is to do that with all the people all the time, and then look at their sleep and heart rate and the physical activity, etc. And also will connect it to some other things, and I'll talk about. Of course, the thing is now how representative can this be? You see, the red stuff is now everyone who was enrolled so far. The green stuff, people have consented but not enrolled yet. Blue parts did not consent. And the one group that, and we've seen it before, is sort of less likely to participate is people 60 plus. So there's a little bit more of an effort of getting people to participate in over 60. And we have seen this before. For the rest, it sort of seems to be an easy. Therefore, that's, you know, it is what it is. We try as hard as we can. That's still an issue. Yeah. So this is recent, but actually this project has been around for a number of years, but from a smaller sample size. So we had about 1,000 people wearing a Fitbit, and as you know, Fitbit measures steps and heart rate and etc. And so one of the reasons to do that is to see whether these Fitbits can pick up illnesses. And COVID was a fantastic example for that, because we had a continuous survey during COVID, and one of the things we asked, obviously, did you have COVID? Or to tell you it's COVID. So in these graphs, the vertical black lines are the date at which people say they have COVID. And what we see in these graphs is how the Fitbit signals respond to whether or not they had COVID. So the blue lines are always people who didn't have COVID, and then the red lines are people who at some point said they had COVID. So the left top looks at resting heart rate, and you see that the resting heart rate goes up just before people get COVID, right? So you see the heart rate signal. If you go to the left bottom, that's how active you are, really amount of steps, and you see it goes down for obvious reasons. They get sick and don't do much. If you go to the right top, this is how much they slept. You see they start sleeping more when they're sick. And then the right bottom is quality of sleep, and you see the quality of sleep is going up. So it seems then that the Fitbit is able to pick up these signals. And of course, right now we're working on machine learning models to see whether you can do this at video level. And of course, this is one of the things in which you could imagine, the future healthcare will develop, in which you would have more passive signals of people's health, and it might be in the case of a early intervention. One other thing is that, I mentioned convenience panels, and it's what we always like to make a distinction between what we're doing and convenience panels. So the biggest convenience panel in health in the United States is all of us. And as many of you may know, it's a volunteer panel. People can sign up. It starts from people go to the doctor, the electronic health record, then they are asked whether they want to participate, and their goal is to have a few million people. I'm not quite sure how many they have involved. And of course, the idea is, like the UK Biobank, is that you have large samples, and you can do all sorts of things you couldn't with small samples. But there's also another part to this, which is selective, and of course, it's always the people's higher education, more likely to be white, and all of that. So there's always the issue, how well does it actually tell us something about the population as a whole? So this is an example that sort of makes that point. So if you have the Fitbit data, they're still based on the smaller pilot sample, then you can, for example, see how good you are in, this is COVID again, how good you are actually in detecting COVID, right? So these are these curves, and essentially the more this curve is to the left and up, the better the prediction, the better one is in detecting the insecurities. If you do the same thing with all of us, that this one, you see it's pretty much the same. So it seems that within sample, the UES or all of us give you sort of the same quality of prediction. But of course, the kicker is now something else. But now we're going to look at forecasting out of sample. So now what we do is we use the model to train on the UES sample, and we apply it to all of us in the big moving sample. And we use the model trained on all of us on our own, on the UES. And if you look at these numbers now, then of course what you see, and this is for looks at males. If you look at these numbers on the left, you see that the leaders actually do really well in predicting COVID among males in all of us. Whereas if you look at the all of us model and you try to predict male COVID infections, it's terrible. This curved line is getting way too close to the 45 million. And then you could do similar things for white and non-white, and each time you see that the one on the right is much closer to the 45-degree line. The 45-degree line means you might as well flip a coin. I know that's what it means. And then you have the same one for education. So the point we try to make, of course, it's partly because more money to do this, is that actually having a smaller representative sample is often better than having a big convenient sample. Of course, it all depends on the purpose. In a case like this, it seems to be good. And this is just the paper. All right, so then having these Fitbits, we also we have done some of it, and we have a proposal where we give people Fitbits at work because we want to look at physical demand and job and measure it objectively, not just asking. Marco Rizani in Canada, Michigan, they have a project on caregivers, and they give Fitbits to caregivers to also measure physical burden of being a caregiver, in addition, of course, to mental. And of course, the Fitbits is not just how hard you have to work, but also well you sleep for it. The sleep is an important part of burden. So that's sort of one set of variables that we play. The other one is air quality. And I'm going to just go through this. No, I'm going to try to go through most of it. So this is, we have people wearing an air quality monitor, and the thing is called an Atmo tube, and you may have actually seen it. You can buy it at, I think the stores actually, so it's not pretty well spread. So you wear it, it measures fine particulate, measures particularly PM 1.0 and 2.5 and 10.0, and also VOC, which stands for volatile organic compounds. And volatile organic compounds, things like paint, smell, or other things. These PM measures are all highly correlated, so I'm going to show you one or two graphs of just one of the PMs, where they're all the same. So the idea is you wear a thing, you need an app, connect to the app, and then of course we get the money from, we pay the money, we get the information from the app, because we do our analysis. And so this is just one example of what you get. So this is a multivariate analysis in which the left-hand side variable is the fine particulate matter, and then the right-hand variable is just a bunch of demographics. And so a high number is bad, because the higher the number, the worse the air you're breathing. So for example, if you look at race, you're probably not surprised to see that blacks are the ones who breathe the worst air. You look at employment, if you work, then actually the air quality is a little better than the air quality when you're not working. If you look at income, the more income you have, the better the air you breathe. Higher education, the better the education, the better the air you breathe. And interestingly, also age. So the older you are, the better the air you breathe. And that's a little strange because we also find that employment actually gives you better air quality. I can only say this because now in itself, this is interesting, but we also want to validate whether these measures actually correlate with something else. So, actually, I'll get to this. So this is just if you look at the pattern over 24 hours. So the horizontal axis are half hours, so 30 minutes. So if you look at, for example, the left side graph, the bottom is at 12, so that's at 6 a.m. So the best air quality is at 6 a.m. Then people wake up and they start making breakfast and all sorts of things. You see the air quality go down. Then the horizontal part on the left gets roughly lunchtime. And then gradually it goes up, and the worst time in the two of all three, the worst time is around dinner time. So dinner time is the worst time in terms of air quality because people are cooking, get together, and you know, a bunch of people in the room by itself probably doesn't really help that. So you see these patterns that you would actually expect. Now, you also want to validate it. So, and so we want to relate this to external sources of air quality. And so there's a group at Washington University in St. Louis, and they do a lot of work. They use satellite data, ground station, they model air quality. And since 75% of our respondents have also given consent to use GPS coordinates, we can then link where people are to modeled air quality from this external source. Now, the problem with the external source at the moment is that the data they produced until recently were quite a few years out of date and only monthly averages. Recently, they gave us some daily data for 2023, but they're sort of catching up. And by 2027, they should be up to date, and we should have almost real-time data. The Admiralty data are minute by minute, so we'll never get minute by minute data from the modeled air quality. But we have available. So now we have at least some of the data 2023, and we do see that it is indeed positively correlated, but the correlations are small. This requires a lot more. And now including the fact that because people spend a lot of time indoors, right? And the correlation between indoor air and outdoor is relatively so just that. On the other hand, you know, if you want to understand people's health and people's development, you know something like that. And by the way, not surprisingly, perhaps air quality inside the home is always worse than outside. Okay, so another example of passive data is actually use the survey data themselves. And this has become known as paradata. I think May Cooper is the one who coined the phrase. And so what it really does is just, and this is mainly done by Stefan Schneider as one group of people. So what it really does is it just looks at how people are responding to surveys, how fast they are, do they go back, how often do they say don't know, do they give contradictory responses. For example, they would say, I have no trouble climbing 2 flights of stairs, but then I find it really difficult to climb 1 flight of stairs. Mistakes like that are being made. And also we started looking at mouse movement. But yeah, so the idea is by looking at that, you actually learn something, not only whether people are serious in answering the questions, you also learn something about their cognition, and that's really what this is about. So the idea is that, you know, if you analyze this well, you may actually get sort of low-cost, easy indicators of cognitive function. That's really what this is about too. So this is a graph that sort of makes that point. So this is what's called figure ID. The figure ID is where you get five little figures, and you have to say which of these 5 correspond to another figure that you show on the same page. And it's a measure of speed, because the idea is you do this as quickly as you can. So this is an example where we have a pattern by age of 2 things. We have this test, the figure ID test that you administer every 2 years. And then we have this measure based on how quickly people ask questions. And as you can see, the pattern over time is pretty much identical. So you find sort of the same pattern as age. And we look at many other things, we find very similar patterns. So the problem one looks at the same thing, but now it just looks at different educational levels. And again, you see the correlation between maybe not quite as high. So the first thing is, of course, in theory, this gives you a way of early finding out about cognitive decline. Because if you interview people over time, you can just look at the change over time, and you can see that some people deteriorate much faster than others. And I guess we know now there are many other indicators people look at. There's some papers that look at financial behavior, and people start doing strange things with their bank account. That's often a sign that something is going wrong. Of course, the second thing is that it's also, we don't do cognitive tests that much, right? Cognitive tests are sort of elaborate, and people go to a lab and they unit for that. And here, of course, people do surveys a lot. And I'll give you one example. It's actually a proposal that Stefan Schneider has resubmitted as an offer. I'm sure you have all seen numbers about the number of people suffering from Alzheimer's disease in the world, or the number of people having dementia. Well, most of these numbers are made up because the many countries they have never tested people for dementia in any serious way. In some countries they have a hospital and they've counted the number of people in the hospital and they have to show that somehow So the question is, are there better ways to get these numbers? And the answer is, well, one way is to look at surveys. For example, the Gallup World Poll is done across the world. And there's a number of other, there's the World Value Survey, a number of these representative samples. So essentially, by just looking at the quality of answers to these surveys, you actually get a better estimate of the incidence and prevalence of dementia. And just an example, this is an example of this. There's much more information you people do in a survey than just the answer. And then the third one is that, of course, and that's particularly true of the US, if they do freedom surveys, you have freedom measures. And this graph illustrates that. So this is number series. So number series are things like, I say 1, 2, blank, 4, right? And you're supposed to say 3, right? So that's a measure of drug. So these are just a bunch of US participants. The red dots are when they do a formal number series test, and that's every 2 years. And then the little pluses are all when they do a survey, right? So it just illustrates how many measurements you have relative to the number of tests that you do. And then, of course, you can look at, for example, how that relates to, let's say, getting COVID or being tired. So we know that people have trouble sleeping. We find this from the Fitbits. We also see that the quality of the survey, for example. And then, once again, if you want to sort of know where this works, if you try to put it all together, you look at, for example, age pattern, then you see that this test in the survey paragraph with the same. So it's not perfect, but it correlates and it gives you information that's not enough. And again, these data are available. So, but actually, what we not have, it's almost there, but we not have done quite. So the point is that for every survey that we tell the IDs, we have extra data that will tell you something about the confidence score of people when they do the survey. So you get a lot of fine-grained information. But then we do mouse movement, we've just started. But mouse movement, same thing. If you ask internet, then how quickly you go to the right answer tells you something about people's confidence. But they hesitate. But that's still the early stage. We do genotyping. I mean, I sort of did this for completeness, but I have really nothing to say about this. And the reason is that we started this relatively recently. The idea of the genotyping is that we will produce a bunch of risk scores and then particular risk scores related to Alzheimer's, which of course is why NIA pays for it. And the only thing I can say is that at this point we have about a little less than 10,000 people who have asked whether they want to do that. We get about almost 6,000 people who have now actually sent back saliva. So we have to consent them, send them a kit, they spit into a tube, and then it gets sent out with a brief, with the label to the University of Michigan. But you haven't really analyzed yet. So the only thing we have is a response rate. And of course, this is the first round, which you often do in this case, you wait a year, you go back and ask anyone who said no, you don't ask again. So the hope is to get maybe 70% or 70%. I'm not quite sure yet. But again, of course, this will be available at some point and sort of adds to the information. Other variables, I mentioned some of you are going to play with glucose monitors. We got 3 glucose monitors, interestingly enough, so we have, because that's important if you know we look at. Some of you will know what Plasso is. That's a device that pricks blood on your arm. And that is another one that hopefully will also get us relatively cost-effective ways of measuring some biomarkers. And then, anything else that you can think of interesting. Exposome. So exposome is that used to be contextual data, now it's called exposome. And of course, essentially, we link everything that geocoded we want to be able to link that to where people are. So, because we have to use addresses, so whenever is something that's related to, can be related to the address, related link. So this is just a bunch, this is just summarizes. Of course, 6,500 variables doesn't necessarily tell you much, but there's a lot of stuff that's in the story. And this website, I'm not going to talk about this. We have sort of these three categories: physical environment, social environment, policy environment. But again, just anything that's useful, so the distinction doesn't. And the reason why I'm running through this a little bit quickly is that, and then you can leave. So the reason why I'm running through this pretty quickly is that, first of all, it's important to know the current people's current environment, but we also want to know about the past because we're interested in how people's lives evolve over life cycle. And to the extent that these geocoded data are available in the past, now you know something. That's, for example, if you know something about where they went to school, and you know something about school quality, you can relate current outcomes to school quality in the past. So that's what we're trying to do. So therefore, we start with residential history surveys. And this may not be the most readable graph, but essentially people get a timeline. So you start at birth, and then you say, you know, where did you live, what's the address, and how long did you live there, and then you go to the next one. So here's one that I filled out actually. Then it's all Google Maps, so you can go Google Maps and see where it's actually right. And if you say, well, what I did is not right, you can move to the market. And if you want to sort of remember what it looked like, you can actually Google Street View. So I lived there as a student, and I can tell you it hasn't changed. It's a long time. So that's the way we do it. And then of course the external sources. It turns out that so far about 60% give us complete data. So then we went back to people who had gaps, like for example, they would skip part of their life or something like that. We upped it to 67%, but there's still a group that really hasn't used all of them. So I'm not entirely sure yet what we'll do. Partly we use other information like for Nexus, you can use credit card information, things like that. But, and the other one, of course, how the quality of the data. And we have at least one check because if they have been in the panel for a while, we know their address. So at least we can see whether the last 5 to 10 years is correct. And the answer is sort of, 78% seems to be consistent, but 28% give us something that isn't quite right. So there's still a lot to be learned about, but of course we also have means.
We have about 10 minutes.
Yeah, so I'm going to skip that actually. Essentially, what you made is that you send people prompts and you ask things, and we have used this in a number of different ways. Skip that. Because I wanted to talk a little bit, why are we doing this? Apart from the fact, to be honest, of course, mainly so I think the best. So there's really two reasons I think to do this. One is there is a benefit generally of having something that has very rich information because you have baseline information the moment something happens. For example, when COVID happened, at least we knew something about people's cognition. So there was a story that COVID was bad for your brain, but at least you could compare before and after. That's an example. And I'm going to give an example about GLP-1 with weight loss drugs. But the second one is, and that's really what this GLP-1 is about, you really want to understand how people's lives evolve from birth and what influences memory on them. And I used to call that, understanding the equality. Why that? Because that's really what why is it different people and what we did. So the first one is GLP-1 use. So at some point, these are the two people doing it today. We started asking respondents where they were actually using weight loss drugs and also whether they kept doing it. So we go back and we want to say, I still use it. And since we have baseline, right, we know a lot about people before they start. We can then compare, we can really look at the changes. So, for example, the first one is, we can look how use has changed. And as you know, there's now a whole bunch of competing drugs. So each of these numbers tells you, which drugs on the market and how market volume has changed over time. So you see these vertical lines that tells you when one of these came on the market. The other thing, if you look at the top graph, the sort of dark purple part is people who get it for diabetes, but then the bluest part is for everyone else. So right now you see more people are using it for weight loss than for diabetes. The other one is, how do they get the drugs? And it turns out, and there's no other source I think that we find that. We find that about 40% doesn't get it from the doctor. They go to compounding pharmacists, they go online, they get it from Canada, sometimes get it from friends, interestingly enough, in some ways. So it's important because it also means monitoring the effect and monitoring the side effects is really difficult, because if you only look at the official provision, you're really going to miss probably the most problematic part. And also, people, they use it for a while, they stop, you see the side effects. And so, for example, that's the first thing, right? So you look at weight changes. This tells us the weight change. It's only 6 or 7%. You would say that's very low because the clinical trials give you much bigger number. But this mixes up everyone. People use it for a while, then they don't use it. They use half the dose. So the population effect isn't all that dramatic. But if you look at sort of people are very consistent and use particular drugs, then you see that it's fine. It's pretty much consistent with clinical trials. And then you look at other outcomes. And so, for example, it turns out the resting heart rate goes up in the beginning if they're using. Heart rate variability seems to be going down. Cognition, actually, some of them seem to get better, actually significantly better, particularly executive function, processing speed. Some of the others, we don't see the effect. And it seems that people generally feel better, so the life satisfaction seems to be going up, and they say their self-reported health score. And of course, the thing is, more people are using it, we follow them over time, so we get more information. And of course, we're giving Fitbit to everyone, so we have more of a chance to look at the effect health and to use physical activity. We have already seen some. So that's still good. And then, of course, we're going to do. So that's sort of one thing. So the other why is really, and this is just a very simple example, what you really try to do is sort of have something that gives us information about the whole population and how things move over time. And I'm going to sort of do this in 2 bits. And this is very preliminary. We're at the end of the 3rd year of our grant. So this is really what we're supposed to do in the next 2 years. So this is very, very, very preliminary look. So as this says, we're trying to collect as much information as we can, both now and in the past. And then the idea is to be able to trace out how life course factors result in observed health or social outcomes. So here's just examples. Right? I'm going to do 2 things. I'm going to give just a couple of color graphs, and then you see, and then I'll do a little model. No, I think 4 minutes.
Questions, Mike?
Okay, then you know what? And I'm going to shift it. I just got one example of how this would work if we do all the data. So this is an example of numbers like cognitive score. This is the average of the sample. And the question is, can we somehow explain how this comes about? So we do an exercise where we want to see what's the effect of the father's education on people's cognitive score in this particular case. So we have an equation, and what we do now is the average in the population have a little more than high school. What happens if everyone would now have, if all fathers would now have quality? And the answer is you get this dashed line, right? So you have a little more, you increase father's education quality, and it has a lot of effect. Now the question is, where does this come from? Well, the first thing is, if the father has more education, maybe the childhood health will be better because maybe you go to the doctor. And you see the effect of the sort of small dashed line, it doesn't really do much. But then it also affects the child's education. And now you see this orange dashed line, and you see this really makes a difference. Okay, so one mechanism, one channel, if you like, from the parent's education to the child's cognitive score is actually through the education of the child. Now let's also show income. Well, it turns out, you see another line that's a little higher. If you don't add income, it adds a little bit, but not much. That's sort of And of course, this is completely unrealistic model. It's sort of the kind of exercise that we aim to do. So the story is that if you believe this exercise, that if you look at the effect of funding education on child's education, health, income, etc., it explains about half of the change. Right, but the other half, right, there is still this gap between the top line and the line of bottom. And then the question is, where does that come from? That's what motivates doing, because then we say, well, no, we haven't really looked at neighborhood effects yet. We haven't looked at quality of education when you grow up. We haven't looked at pollution in the growth. So that motivates why we try to do all of that. And in some, ideal world, you would sort of end up with able to explain variation for people and also the mechanisms that will tell you how to scale.
Study. And there's a lot, are there a couple of questions that you?
Thank you so much for coming and telling us about the data. I recently signed up for access to the panel, and I was really struck by how easy it was to get through the approvals process and how much data was available for analysis. So it's an amazing platform. My question was, do you accept survey experiments as well? Can people propose experiments? Or is it just, because I was thinking, the TEST program, the time sharing experiments in social sciences was recently discontinued. So I was wondering if your platform, given this incredible resource you built, this is something that people could use for experiments.
The answer is a qualified yes.
Like,
What?
Like-
Oh, sorry, yeah. So the answer is a qualified yes. There are two things. So we have actually done experiments. And of course, the concern there as well now, now our respondents have changed because they did experiment, gave them information about customers. It turns out that I think it is like there is one that seems to have a small effect. So what you see is that it's usually an immediate effect in that sort of downward. So you may still have an effect sort of in the domain where you experiment. Doesn't seem to spill over much else. In the data, you can actually see which surveys were related to an experiment. So you can actually look to correct that. The other thing is we also, we still want to grow. We're also thinking of maybe having an experiment in subsample. So I guess the answer is yes, but of course we would also want to look at what is, for example, if the experiment sort of chases our respondent away, then and of course these things happen, right? Very concrete things. I guess so biological.
Any other pressing question we might, Olivia?
I was just curious about how can you check to make sure that when people are responding to the surveys, they're not using AI to respond?
Yeah. Well, the short answer is yes. I think there are two reasons why I'm not worried yet. And the first that was not that common. The other one is that we select our respondents. The respondents do not select us. And if you think of course, the most notorious example of convenience sample is MTurk. And I'm part of a paper with some people at Rand, and people were asked about a number of health conditions, and they were concerned about the truthfulness of the answers. So there was a list of maybe 8 health conditions, and there were 2 added, and they were non-existent. And it turned out, if you did a proper analysis, 25% of the respondents gave you health conditions that didn't exist. And MTurk is freedom, not everyone's exists. So the point is that, of course, these people do it to make some money, even though it's a big set. So I think if you have a confidence panel, and if you want to make money, and if you're smart and you once sort of put together this AI approach, then you can probably 20 respondents, 100 respondents. In our case, I think, first of all, you can never be more than 1 respondent. So you select only 1 respondent. And secondly, the probability of finding someone who thinks it's interesting enough to invest in having AI using to answer our question, I think. But I guess I'm sure it's real. I don't think it's materially very important yet. But hopefully we can get much help.